Yeah, I forgot to record. I'm sorry. All right, that's not no problem. Let me do it here. Guys, you have Zoom, correct? So how you will know if it's a unicast or multicast? From the first byte, okay, and you check the last bit. And if it's the last bit, if this one's 0, that's mean it's a unicast. If it's 1, that's mean it's a multicast. Correct? Now there is a special case. There's a special case from the multicast when as the first byte is 1, 1, 1, 1, 1. That's mean it's a broadcast. What's mean a broadcast? You send it to everybody. So you have a 3 option. Either you send it to one computer, or you send it to a multiple or more than one computer. And the last option when you send it to everybody. So that's the unicast, multicast, and broadcast. So that's going to be one of the exam questions. You know, what is the first byte is going to look like when you're trying to send a broadcast? So it has to be all of them once. So that's the answer. All right, so let's do some example here. Now, if I have a MAC address, start with 4A. 4A, is that unicast or multicast? Who can answer that? I have 4A. Is that unicast or multicast? What's 4? 1, 0, 0, 0, correct? That's no. 0. Okay, so is that multicast or unicast? Unicast. Why? Because that's 0. Okay. The next example. 47. I'm sorry, guys. I made a mistake. It's not the first. I'm sorry, not the first hexadecimal. The first 8-bit. All right. So the A, it's 1010. So that's unicast. Second example is 47. If you have 47, what's the answer? It's multicast. Why? Because it's 0, 1, 1, 1. So the last bit is 1. Now, what about if you have a MAC address look like something like that? What we call that? Broadcast, right? So again, let me repeat that. So 4A, it's a translate to 0, 1, 0, 0 and 1, 0, 1, 0. So I'm looking for the last bit, which is 0. That's a unicast. When I look at 47, all right, so the 7, it's equal 0, 1, 1, 1. So the last bit is 1. That's mean it's a multicast. I'm sorry, a multicast. And finally, when everything is F, that will be, yes. Which one? That's when you send it out. No, that's the actual how it's look like. That's the address. That's the actual address. When you send it out, it's going to come as a stream. That's when you send it out, yes. But that's not going to decide when you send, because when you send it out, it's going to be the opposite, correct? But that doesn't mean that's a unicast. You know, that's how they communicate it, how they send it out. But the actual device, based on the MAC address, from the MAC address, can tell if it's unicast or multicast. Next step, when you try to send something from that computer, then you have to switch the bits. You have to start from left to right. Okay. And that's what we explained for you, correct? So the address sent from left to right, left to right. However, each byte would send from right to left, right? So that's going to come in the exam. So I will give you an example like this. I will tell you, okay, let me move this one up. So I will tell you how you send this MAC address out. How you send this one out. How you send it out? We'll send 4 first, correct? Then 7. And what's 4? Correct. So first of all here, so we send this one. What this one? That's the 47. Correct? What is the 47? What is the 4 first? 0, 1, 0, 0. What is the 7? 0, 3, correct? When you send it, how it's going to look like? 1, 1, 1, 0, then 0, 0, 1, 0, which is this one. All right. So that's one of the questions in the exam. Easy question. Now let's talk about the actual implementation. Now we talk about, you know, the Ethernet technology, how the frame it's going to look like. We say we have the data it's coming from the network layer. We have to add header and trailer, correct? That's what you have to do. You have to add the header, and we know what's the header. What's exactly the header look like? You will have the source address, destination address, you know, the SFD and the CRC, all the stuff. You add them, then you send it through physical. Now let's talk about the actual Ethernet card. So the Ethernet came, you know, to this world 1976, correct? So that's when the Ethernet technology started. And when it started as 10 megabits per second. So it was slow. You're sending 10 megabits, bits, in each second, which is slow. Then it's got improved. We increase it from 10 to 100. And that's, we call it fast Ethernet. Then after that, we improved it more to the gigabyte Ethernet. So it's, 10 times faster, correct? Then after that, we did from 1 gig to 10 gig. All right, so that's, we call it, 10 gig Ethernet. So we start with the standard, then fast, then what they call it, gigabyte Ethernet, then finally 10 giga, byte Ethernet. Now let's talk about more about them. Okay, so the Ethernet technology, who introduced that? As mentioned before, IEEE. And what they named it? Remember the project, the whole project, what they call it? 802. Now for the Ethernet, they name it E02.3. All right. And what they are using in the Ethernet, what is the concept? How you manage the communication through the Ethernet. So they use something called, what they call it? CSMA/CD. What is that? What does that mean? It's carry and sense multiple access with collision detection. All right, so it's carry sense multiple access with collision detection. Can you explain that for me? Does anybody can give me a hint what that's mean? Just from the name, so we don't have how does that work. What do you mean carrier sense? Yes, carrier sense. So what is the carrier first? What is the carrier? How you carry the data in the Ethernet world? Cable, correct? So maybe a cable. All right. So first of all, the first sentence, carrier sense. We know carrier. It's maybe the cable. What do you mean by sense? So what you're trying to see, you will try to sense the cable, see if there is somebody else sending data. So before you send anything, you just access the cable and see if there is anything happening there. Is the cable empty? It's ideal, nobody's sending. So that's the first step you have to do. You have to send the cable, see, can I now send or I have to wait? Is anybody else using the cable or the media? So that's the first step. Second, part of the name, multiple access. What that's mean? That's mean this media could be accessed by multiple device. All right. So because that is a shared media. It's only for me. There's another computers, another printers, another device, you know, trying to use this media. So that's why I have to check the media before even I send anything, because that's not only for me, it's shared with the other devices. Then let's discuss the collision, you know, detection. What's the collision detection? Correct. So even you sensing the media, okay, you check the media and you feel, oh, nobody's sending anything. Is that always correct? Okay. No, maybe because maybe in the same time, I'm sensing the media and another device is sensing the media. So at the same time, both of us, we notice there is no activities. There's nothing there. So I will assume I can use it now because nobody's using that. And the other device in the same time, check it and say, oh, there is nothing it's happening there. I will use it. So now in the same time, I'm sending and the other device sending. What's going to happen? You will have a collision, correct? So the data will be collided together. You will not know if it's my data or the other device data. So in this protocol or this concept, we will try to find a way to detect the collision, if there is a collision or no. So that's why the whole algorithm is based on sensing the media and detecting the collision to eliminate the collision. That's the way how to do that. So that's in the Ethernet, that's what they use. They're using the CSMA collision detection, correct? All right, we said, I'm not gonna go that only. So only one station at the time can use the media. If two devices sending the data at the same time, what's gonna happen? We will have collision. So that's why we need one device to send data at the same time. Okay, now I'm sending data. Remember, when I'm sending data, I'm sending that to everybody. So that's why in our frame, what we will have the source and destination, correct? So if I'm the destination, I receive the frame, what I have to do? I open it, correct? And I see the destination is my address. So what does mean? I receive the frame, I open the frame. Remember the frame has source and destination address. And I see this destination, it's my address. What I have to do? Keep it because it's coming to me, correct? Now device B received the same frame because you send it to everybody because it's a shared media. And device B received the frame, open it and check the destination. And what we found is not the B address. What's the B device will do? Discard the frame. It's not mine, so I don't need it. All right. So that's the whole concept, you know. It's a shared media, everybody listening. I will grab the frame, it's mine, that's good. If it's not mine, ignore it. All right. Again, why you know, we're trying to eliminate the collision. Can we eliminate the collision completely? So we'll see some scenario, we will have a collision. Now, if you have a collision happen, what you have to do? So I have device A, I have device A sending data to B. In the same time, C is sending data to D. All right. And then collision happened. What you have to do? What's A and C will do? Before reset, what they will do? They will have to terminate the connection, sending. They have to stop sending. Then after that, they will start from beginning. You know, they will try to resend, but again, they have to check the media first. So they will try the same process again. But what they have to do immediately when they see there's a collision, both of them, all the devices who have the collision, stop sending and discard what they send already, because that's now doesn't make sense to have them. I would stop. Anything I received, I have to discard because it doesn't make sense. Okay, clear? So the chat, you know, the chance of collision can be reduced if stations sense the media before trying to send it. So that's gonna help, you know, that's not gonna eliminate it, but I will check the media, nothing happening there, I will send. I reduce that risk. However, still I'm not eliminating that completely. And that's why we need the collision detection. So we'll see how. All right. And why we will have a collision? Because we will have something called the propagation delay. And we'll see that's why. And by the way, that's, remember when we keep that in mind, remember when we said minimum has to be 46 bytes, correct? The reason behind that is the propagation delay, and I will tell you why shortly. But let's go here now. All right, so now I'm trying, always I'm trying to look back, but that's fine. So now I'm trying to send data from B, device B, at time 1 to where? When you send data from A or from B, where do you send it? You send it for everybody, you send it out, okay? You in the media. If it's for A and A will receive it, will check the destination address, mine, I will keep it, does not mine, discard, correct? So now what's gonna happen if, all right, at the time T2, okay, you know, I'm sorry. And again, that's before the collision detection, all right? So let's say, you know, at, can I do that? Yes. So at this time, okay, B send data to A. Remember, there is a delay always. There is a propagation delay. It's gonna take time to receive the destination. So you're sending it here and A until A will start receiving the data. Now, in the same time, if you see here the time here at D2, C, remember now it's the frame, you know, the media is it's free. So now C will think, you know, I can send. What C will do? Will send the data. Now at this time, now C will send the data and everybody. Now what's gonna happen here? You see this area? Oh, this area, you have a collision here. All right. So in this case, what's gonna happen here? What you have to do? What C and A will do, or B? Terminate and discard all the data. Terminate because they have, you know, collision, correct? Now, what's the point here? What we have to use to improve that? We have to use the collision detection. All right. So, now you're trying to send data. A trying to send data, correct? And it's take up to, that's the termination transmission time. So up to here. So until, you know, at this time you're sending data and C still not seeing, you know, there's data coming. So now C sending data at the same time. So at this time, okay, C send data. When it's the collision happen, it's gonna happen at this point, correct? So in this case, when you have a collision detection, what you have to do? So C terminate, you know, detected there is a collision and aborts. Same thing, you know, A will receive, you know, they will detect the collision and terminate here. Now the question for you, if A send the data already and I finished, I'm A, I send the data and I finish the sending. And then C send the data, but I already finished, I send them out. Then in the middle, collision happened because C sent after me, but I finished early. So now in this case, what we'll have? What's gonna happen here? remember at the Ethernet, when I finish sending, I will assume I'm done. I finished. I'm good. You know, I don't have to worry about anything. I don't have to resend. I don't have to do anything. So the problem here, if I'm sending data, okay, and the transmission time, it's less than twice the propagation delay. Because remember, when you send the data, when you send it and receive the collision, detect there's a collision and send the signal back to A, it's going to take something called propagation time. Then it's going to take another propagation time. So if I'm finishing before the two of the propagation time, I will not know there is a collision. I will assume I'm finished. So that's why, if you remember, we mentioned the length of the data has to be minimum 46. Why? Because from this equation. So let's go back here. So let's say, you know, in the media, our propagation time is 25.6 microsecond. Perfect. Now, to send data, and it's to send, if you're sending data from A to C, it's going to take 25.8 microsecond. Now let's see, let's assume there is a collision there. Then C detect the collision and send the signal. I have a collision. How long is going to take for A to receive a signal? Another 25. So how much time you need to be able to detect the collision back and forth? You need 2 multiply of the propagation delay. So that's why if you see the equation here, the time for transfer time for the frame, it has to be twice of the propagation delay, correct? Which is 51. Now, if my speed is 10 bits per second, okay, and you multiply that, the speed multiply with the time, then how many bits you will have? 64, correct? So that's why the minimum you have to send 64 bits. Remember the 64, there is 46 data and there is 18 for the header. So the total has to be 64. So that's why when we say 46 data or 64, the frame, the size of the frame, correct? Because this 64, it's 46 plus 18. Remember the 18 is the header and the trailer, correct? So that's the total. That's why always we have to add the 18. And that's why the reason why we have to have a minimum length, because of the propagation delay. To send the data to reach to the other end, it's going to take 25 seconds. And then if you detect a collision and you send me a signal, oh, there is a collision, it's going to take another 25. If I finish before the 50, I will not know there is a collision. I will assume I'm done. That's why they say you have to send at least 64 bits. The frame size has to be 64 bits. So that's another question in the exam. I will tell you, what is the, the propagation delay. I will give you some numbers and you will do the math. All right, it's a simple math. Is there any question so far? So now how the carrier sense multiple axis collision detection works. So let's say, I'm trying to send a data. So how that will work? What I have to do, I'm ready. What I will do, remember? I will send the media, sense the media. If there is a media busy, what do you have to do here? Okay, I have to wait. I will just wait. If channel 3 is not busy, then what I can do, I come here. Here, what I have to do, check if it's done, if I finished sending. If I'm not done, what I have to do, I will just keep sending. I will go back. I will keep sending until I finished. Perfect. If I'm done, I will go down here. Now, then what will have collision detection? Is there a collision? If there is no collision, done. I finished successfully. There's no problem. Now let's go back. I finished sending and there is no collision. What I have to do, we'll come here. Now I will check. Do you have a collision? If yes, then what I will do, I will send a jam signal. That's the jam signal. It's gonna stop everybody. That's to abort the sending. That's why we say it has to be twice of the propagation delay. And based on that, we decide we have to send 64 bits. All right, clear why 64? Because of that. Because when I send a jam signal, it's gonna take another 25 seconds to reach. So if I'm done already, it's done. I will assume I did a good job and my data went to the other side. Then what I will do, I will use K, and K, it's a random number. Why we did a random number? I'm sorry, before that. K, it starts with 0, then it's incremented. Why we do that? It will allow you to try to send the frame 15 times. You know, after that, there is an issue. If you're trying to send for 15 times and still the collision happen, there is something going on, correct? So then you start with K equals 0. If there's a collision, you go back, try again. Then if it's still you have a problem, K will be 2, then 3, then 4. Then, you know, you will try. Now, if K less than 15, okay, you will continue, you will go back, try to resend. All right. If it's more than 15, you have an issue. What you have to do? Abort. You know, there is an issue. You have to fix it. Now, then we have to wait for a random time. Why? Why we have to wait for a random? Yes, but why it's random time? Why would I have to wait for a random? Remember, if you have a collision, the other device has a collision, right? So if both of you trying to resend at the same time, so the collision can happen again. That's why I will do random time. So when I do my random, maybe it's going to take after 15 seconds, but the other device will try after 5 seconds. So the time is different. So we'll not try to send again at the same time. So that's why we need a random wait time. Clear so far? So that's how what do we call it? Carriers sent multiple access collision detection, how that will work. All right. So now let's go on actual example. Yeah. Yes. Again, if collisions can happen, then you have to try again. Yes, you know, you cannot force them, because when you do a random, you know, there is a chance we'll have the same random number. So there is no way to eliminate that. So let's go back very quick here. So I'm gonna go over this what we did. Sorry. All right. So I will skip how I will skip this. You know, this one is just to tell you, you can read it by yourself. That's gonna tell you the type of cables. So for example, when you see 10 base 5, what does that mean? Can you tell me what's 10 base 5? When I see data, when I see a cable, say 10 base 5, what's 10 mean? 10 megapixel per second. Okay, pixel per second. Okay, what's base? What is 5? So 5 is going to tell you what is the length of the cable. So 5 in this case represent how many meters? 500 meters. So that means you can use up to 500 meters. After that, the signal will not be good. You cannot use longer than that, right? So now, if you have something, you know, what about base 2? It's 185 meters. It's close to 200. That's why we name it 2. All right. So that's just names. You know, that's how they name the cables. What about 10 base F? Fiber optic. They used, you know, 10 megapixel using fiber optic. Okay. What about T? T twisted pair. That's what we have in the Ethernet cable. It's a twisted pair. You will have 2 cables that twisted together. What about, you know, okay, so that's one of them. What about, what's the next one? Something we call the coax cable. That's what we use home. The cable coming to our house during the net internet provider, they're using the coax cable. And so there is two types. There is shielded and unshielded. The shielded, it's more secure, has a shield. It's for secure, make it, you know, to eliminate the noise and the interference. That's why I use the shielded. And usually that's for external. When you're running that external, you want to make sure it's insulated very well. Within the house, they're using the unshielded one because it's, of course, cheaper. Okay. Same thing. You will have 10 base T. It's for twisted pair and for fiber. All right. After the standard. So remember, we start with the standard. What is the speed of the standard? What's the bandwidth for the standard? Ethernet 10. Now then we have to, you know, go advance and we have to upgrade that to 100. So then, you know, they introduce the fast Ethernet. And what's the purpose of that? First of all, increase the bandwidth to 100. What is the second? To make sure it's compatible with standard, which is mean if my computer is connected through or my Ethernet device, it supports only 10 megabits per second, still I can communicate with 100. Still we will be able to communicate. I don't have to communicate only with 10. If I'm 10, still I can talk to 100, 1 gig, 10 gig. Still I have that, the point here. Keep the MAC address the same. So we are not changing the same size MAC address. Okay, keep the same frame format. So we're not changing the frame. So the Ethernet technology, they will use the same format. Doesn't matter what is your speed, what is your bandwidth. All right. Keep the minimum and maximum frame length. So that's the way how to be able to communicate with others. So what we did, simply we just kept everything same. The only things we did, we upgrade that bandwidth. All right. And we communicate with the slow band. So that's the purpose here. So again, you don't have to worry about that. So now in the fast speed, we're using all of the star topology. We're not using the bus anymore. You remember what is the star policy? What is the star topology? You will have a sender device. This sender device will do as the main component. It will communicate with the other devices. So if I'm trying to send a data from A to B, it's not going to be a direct to AB. I'm not going to use the bus. I have to go through either a hub or switch or router. All right. So what is the new feature added? So they added something called auto negotiation. What is the auto negotiation? Simply, you know, yeah, I'm 10. I want to talk to you. You 100. So can you please let me to talk to you with my speed? All right. So the same thing in the 100 when the 100 bandwidth device trying to communicate with 10. Same thing, they would negotiate and say, no, can I send you data with slow bandwidth? Because you have to. I cannot. I'm Ethernet, and I can only handle 10 megabits per second. You cannot send me 100 bits in the 100 megas bit in in 1 second. I cannot handle it. That's too much for me. So that's why they have to negotiate. We have to talk to each other. I'm 10, you 100. We have to use the 10. We cannot use more than that. All right. So that's the new feature. What they did, they added this feature to be able to communicate with the other devices. All right. Again, the same concept here. The naming changed from 10 to 100 because it's 100 base. So now it's handling 100 megabit per second. And from the name, TX is just a regular table, and it's up to 100 meter. FX is fiber, and it's up to 100 meter. And either a twisted pair. That's usually what we use in the Ethernet. These days it's twisted pair, and it's four pairs, which is actually that's what we have. I don't have it here, but that's what we have. Clear? After the fast, what we did? We don't have to go about the cables. That's something you can go over it. So after that, we went from 100 meg per second to 1 gig. Okay, what is that? What is the change happen here? What is the change? Not much. The only thing here we changed, we upgraded to 1 gig, and we kept the MAC address the same size. What else we did? We left the frame the same frame format. We did not change that. And what we did? We still kept the auto negotiation. So if I'm 10, still I will be able to communicate with 1 gig Ethernet. So that's very important. So almost all that 1 gig Ethernet using the full duplex. What is the mean full duplex approach? Full duplex, I can send and receive in the same time. And what do you need for that? So we need switch or routers. What is the purpose of the switch? When the device is connected to a switch, each device will have a queue in this switch. So still you're sending data, all the data you're sending to me, I will put in the queue. And if device A is sending the data to the switch, all this data, I will stack them in a queue. Then I will start sending data out. So the purpose here, I can send and receive in the same time because I have the switch. So that's why the switch has the queue, all right? However, still, you can use the full half duplex. What's the half duplex? You can send and receive, but you cannot do it in the same time. So if I'm sending, I cannot listen. I have to wait until I finish sending. So in this case, still you have to use, the hub. Correct? Okay. Now with a full duplex, that's a tricky question. If you have a full duplex, the same time, but is there a collision there? There is a collision? There's no collision. Why? Because everything you're going to one location, correct? So, and in the same time I'm receiving. So I'm sending my data to the switch, and the switch will decide when I will send, correct? So for as a device, okay, I'm sending to one device, and this device listen to me, okay, all the time. So there is no any collision. That's why we call the full duplex it's collision free. All right. For we need acknowledgement, but acknowledgements happen not in the data link layer or physical layer. It's happening in the network layer. Always you need, because still maybe you will receive the data, okay, and there is no collision, but maybe you will have a corruption. Maybe some of the bits switch somehow, right? So still you need acknowledgement, to make sure you receive the right data, right? So that's level at the advanced layers, network at the network and transport layer. That actually the acknowledgements happen at the transport layer, and we'll show you that in chapter 6 and 7 maybe. All right. Again, that's the same thing. It's numbers. I'm not gonna really. That's 1,000. It's 1 gig, and using fiber. And usually those use it for mostly for the back end when you connect, data center with data center. You need a high bandwidth. After the 1 gig Ethernet, what we have? After the Ethernet, after the 1 gig, we'll have the 10 gig. What is the difference? It's the same. The only thing we increase the bandwidth, but we kept the same MAC address size, the same format, nothing changed really. And why the CSMA CD is not used in the 10 gig? As we explained before, why? Because you are using the full duplex. Perfect. That's really the main reason. And usually for the 10 gig, usually is used for the, to connect the main network, like ISPN network, data center. You will not use them to connect two computers. All right, so that's mostly for the back end. And again, you know, we left the same size of the MAC address, the same, you know, format, you know, the minimum and maximum length, we left them the same. So not much really changed. We increase the bandwidth. All right. So is there a question so far before we take a break? So that's the wired network. That's the Ethernet, correct? After the break, we'll go over the wireless. What is the media in the wireless? Ward? What type of media we are using? What's the media? That's a technology, Wi-Fi, but what's the media? In the wired, what we use? Cables, correct? Now in the wireless, what we are using? The air, correct? There is no media to control. There is nothing. Yeah, we'll after the break, we'll go over it. So can you please take 5 minutes, guys? Is there a question over Zoom, guys? That's the advantage when you come here. Some of the students say, I cannot see when I start writing here. Sometimes I have to write, correct? You know, even I'm trying to use my stuff. Oh, actually, you know, let me charge my laptop a little bit.